So back to our example of the jelly beans in the jar from the museum, where there's an equal number of black and white jelly beans of those million jelly beans in the jar. Half the jelly beans are white, half the jelly beans are black. What I have here is our little outcome path or tree diagram for each of the possible combinations in terms of picking a jelly bean from that jar, where it could be black or white. So in this case, this replicates what we had in the class example, where the probability of black is 0.5, probability of white is 0.5. And here are our respective probabilities. There are, in terms of number of black, 0. There's one occurrence where there's 0 black jelly beans where they're all white. For one black jelly bean, there's 1, 2, 3, and 4 possible outcomes, or four occurrences of one black jelly bean. So let's just hopefully you can see that a little better. So 1, 2, 3, 4. So 4 times by 0.0625 is 0.25. Now for two black jelly beans, there's 1, 2, 3, 4, 5, 6 occurrences of that. And then you can see here that's the white, white, black, black, white, black, white, black, white, black, black, white, white, black, white, white, black, and then black, white, black, white, black, black, white, white. It's the last one. So that would be 6 times 0.0625. And as we saw in the lecture, there's the distribution. Now I can change that. I can ask myself, now that I have this, I can ask myself probability questions. So what's the probability of 3 or fewer black jelly beans? 3 or fewer, let me make this a bit bigger. So 3 or fewer would be right here. So 0.0625 plus 0.25 plus 0.375 plus 0.25. I add those up, and the probability of, if I pick 4 jelly beans from that jar, the probability that my pick of 4, that there is 3 or fewer black jelly beans, is 0.9375. The probability of 3 or more black jelly beans is the 0.25 plus the 0.0625. Now, what you can also do with this chart is I have it for 0.5 and 0.5. You can change the yellow to any combination between 0.01 and 0.99. So let's say that 90% of the jelly beans in that jar are thought to be black. I can change that to the probability of picking a black one now is 0.9. And that updates my chart. Here are all the probabilities. So white is 0.1. 0.1 times by 0.1 and 0.01, 0.001, 0.0001. And here is my chart over here and right here. And I can also see that if I ask myself, I fill this chart in here, and if I ask myself the probability of 3 or fewer black jelly beans is 0.2916 plus 0.0486 plus 0.0036 plus 0.0001. The probability of 3 or more black jelly beans now is the 0.2916 plus the 0.6561. So this now allows you to take that diagram or that probability distribution, and you can kind of like fiddle around with it. So I can do 0.99. So the probabilities are really small. And let's make these numbers. Oh. And there's what it looks like. So almost all of them are either that. The probabilities for the other ones are so small. So I can do 0.8, I can do 0.7. There. So it allows you that opportunity to play with this. This is posted to Blackboard. And that ends the jelly bean example.